As the number of farms has decreased in the United States, the average size of the remaining farms has grown larger, as shown in this table. We'd like to find the least squares regression line that best fits this data. First, I'm going to decide on how I'm going to use my numbers, how I'm going to use my variables. So I've got my years here from 1910 to 1997. I'm going to let X be the years from 1900. Okay, so here I have X is 10, 20, 30, 40, 50. You gotta be careful because now it all of a sudden changes. 59, 69, 78, 87, and 97. So those are the X values that I'm going to use. And I'll go ahead and leave the acres, the average acreage perform the way it is. So for our least squares regression line, we're going to use Desmos to do this. So in Desmos, I'm just going to put in my table right now. So I'm going to move this over. To add a table, we click plus and then put a table, and we're going to put our X's and our Y's. We're going to let X be, of course, these years, and Y will be the average acreage perform. So we're going to go ahead and enter these numbers that we have, 20, 30, 40. And sometimes Desmos knows what you're doing, but then ours actually changes a little bit. So you'll have to make sure you're putting in the right things there. Okay, so we've got our X values now, and then we go ahead and put in our Y values. Those are the acreages. So 139, 149, 157, 175, 216, 303, 390, 449, 462, and 487. So there's our table of values. I'm going to go ahead and now look at the graph, and we're going to zoom out. We've got to find these points. I'm going to change the window here. Note that X ranges from 10 to 97. So I'm going to go from 0 to 100 for my X values. And my Y values range from 139 to 487. I'm going to go from 100 to 500. And you can see that we've got some points here. Now, obviously, these do not follow a line. However, we could try and use a line to kind of estimate it, okay? And there are different ways of knowing what the best type of function is. There are other types of functions that would model this much better, but we're going to go ahead and just use a line to do it. Now, in Desmos, to create our line, okay, we're going to use y equals mx plus b, but we'll have to use y1 and x1. So y1, and instead of equals, because it's not equal to a line, we're going to use our little squiggly, okay? And then mx1 plus b. And that gives us our line, and we can see that our line it's a decent trend along those points, and it tells us m and it tells us b, and so we can go ahead and write that out for our least squares regression line. So 4.71795, 4.71795x plus b, and b is 37.9308. Okay, so those are our numbers. Let me just double check that I wrote those out right. 1795. Okay, I'm happy with that. So this is our least squares regression line that best fits the data. This is the best possible line for the data. Not saying that a line is the best way to model it, but it is the best line that fits. And now we're going to use that to predict the average acreage in the year 2020. Well, in 2020, remember, X is measuring from the year 1900. So this is 120 years later, 120. So that is what we're going to plug into to this equation. 4.71795 times 120 plus the 37.9308. Now let me show you that Desmos is actually really awesome because it actually stores those numbers, m and b, for us. So we can actually just type m, and if we type m, it knows what the number is. And you can see it's actually not even rounded now. M times the 120 plus the b. It just stores that for us, so we can use it now to estimate different values. And we get, I'm going to go ahead and round this just to the nearest whole number. It's 604. This is about 604 So based on this trend, if this was a linear trend, we would estimate that in 2020, the average acreage would be about 604.